Hi everyone, today we are going to start 6.2, which is relate transformations and similarities. Let's review some of our transformations that we've learned in the past. We have translation, which is taking a figure and sliding it. Rotation, which is taking a figure and rotating it or turning it. And then a reflection, which is just taking a figure and flipping it over either the y-axis, the x-axis, or maybe some equation. The new transformation we are going to talk about today is dilation. Now, the reason that we didn't talk about dilation before is because it's not a form of isometry, which isometry means that the shape does not change. And you can see in a dilation, that shape does change. The blue shape becomes smaller to become the red shape. So dilation, size change. It's a transformation that preserves angle measures and results in lengths proportional to the pre-image lengths. Scale factor, which we talked about in the last section. Sometimes we use the letter K to represent a scale factor. So it's the ratio or fraction of the linear measurement of an image to the corresponding measures of a pre-image. Dilations and similarity. If a dilation can be used to move one figure onto another, the two figures are similar. So if a dilation occurs, we know that the figures are similar to each other. Triangle FEG is similar to triangle FDH. Describe the dilation that moves triangle EFG onto triangle FDH. So FEG is the blue triangle and FDH is the red triangle. So we know that they are similar, so we need to figure out what the scale factor is. So if I look at this side for my blue triangle, I see that that side length is 10. Now, even though this segment is blue, well now purple that I outlined it, we know that the red triangle also uses that entire side length. So I need to add 10 and 10 together, and I get 20. So if we go from the blue triangle to the red triangle, is that triangle getting bigger or smaller? Well, the blue triangle is getting larger to become the red triangle. Since it's becoming larger, we know that our scale factor needs to be greater than 1. So if I take 20, which is the side of the red triangle, divide it by 10, which is the side of the blue triangle, I end up getting 2. So 2 then is my scale factor. Figure A and figure B are similar. Identify the scale factor of dilation that moves figure A onto figure B. So let's look at our first example here. We see that A is the small triangle and B is the large triangle. So if A is getting bigger to become figure B, we know our scale factor needs to be greater than 1. So I'm going to start with what the side length of B is. Well, I just need to add up 4 and 4. That is 8. So my K scale factor is going to be 8, which is the long side, divided by the small side of my little triangle, which is 4. And I end up getting that this is a scale factor of 2. Let's look at example 2 here. Figure A is actually the large rectangle and figure B is the small rectangle, meaning that A shrinks down to become B, so our scale factor needs to be a number less than 1. So in this case, my K is going to equal the small side divided by the large side, and I got those numbers from looking at this. So 3 divided by 5. Now, I'm just going to keep it like this as a fraction rather than a decimal. Our third example, I start from my large triangle to my small triangle. So once again, my scale factor needs to be a number that is less than 1. So what would my scale factor be here? It would be 1/3. Tell whether a dilation can be used to move one of the figures onto the other. So remember, dilation, if a dilation occurs, the two figures are similar. So for number 4, are these two figures similar? Well, they're not. Just looking at this, we see we have a square here and a rectangle here. A square and rectangle are not the same shape, so we know that those are not similar. So this answer here is no. Number 5, are these two triangles similar? Now this one's a little bit harder to see, but if we look at the angles, we know that if a dilation occurred and figures are similar, their angle measures would be the same. And when you look at the angle measures of these two triangles, they are not the same. So these two triangles are not similar. A dilation cannot be used. Now let's look at number 6. Can a dilation occur here? Well, let's see. Are my angle measures the same? And they are. Next, I need to look at my side lengths and determine, is a scale factor being used for all the sides? Well, let's look. Going from 2 to 4, that's a multiplication of 2. Well, let's look at the next side. 3 to 6, is that a multiplication of 2? Yes, it is. 3 to the 6, is that a multiplication of 2? Yes, it is. And from 3.5 to 7, is that a multiplication of 2? Yes, it is. So a dilation did occur here. Combining dilations and rigid motions. If a dilation followed by any combination of a rigid motion can be used to move one figure onto the other, the two figures are similar. So looking at our triangles here, we start at triangle, the blue triangle. We see a dilation occurred to create the green triangle. And then to become the red triangle, we had our mirror image, which is our reflection. So this triangle, the blue one, to the red triangle, they are similar. Describe the combination of transformation. The two figures are similar. Describe the transformations that will move the blue figure onto the red figure. So the blue figure is our small triangle. The red figure is our large triangle. What transformation occurred here? Well, there's only one, and it would be a dilation. And let's go one step further. What would the scale factor be? Well, our figure is going from small to large, so we know our scale factor has to be a number greater than 1. So I need to figure out what is this total length here for the red figure, and that would be 14 divided by the small side of this triangle, which we know is 6. And I can simplify that to 7 over 3. And that is my scale factor. Let's look at question 2. What transformation or transformations have occurred to take the blue figure onto the red figure? This one is going to have 2 transformations. What are they? Well, the first one is a dilation. What would the scale factor be for this problem? Well, going from blue to red, we are shrinking, which means our scale factor needs to be less than 1. So we get 6 over 9, and that simplifies to 2/3. After the dilation, what happens next? Well, it's a reflection.